Chemical reactions and equations. So this is the first chapter in 10th standard science. So we have to know about physical change and chemical change. This is the 7th standard science chapter. So that chapter is the basic for this one. So first of all, we have to know about some examples of chemical reaction. Those are respiration, digestion, curd formation, and rusting. So you can observe here we have the one common property is here, that is these reactions, they are permanent reactions. We cannot change it. We cannot change it means we cannot reversible this reaction. Respiration, digestion, food formation means growth. These are all chemical reaction. And also combustion. We can burn some paper, that paper will produce some amount of carbon dioxide and ash. We cannot reverse the process. We cannot produce the paper from ash and carbon dioxide. So these are permanent reaction. So we can observe some characters. These characters we can easily identify the chemical reaction. The characteristics of chemical reactions are change of state. Of course, change of state. Paper is solid in state. If you burn the paper, it will produce the carbon dioxide. There is state is changed. State is changed. Of course, next one is temperature. In some chemical reaction, we can observe the temperature. It may be that chemical reaction will produce the temperature or it will absorb the temperature. And the next one is evolution of gas. Of course, in some chemical reaction we can observe the gas production. Best example is burning of paper. If you burn the paper, we can observe the carbon dioxide. So evolution of gas. Next one is precipitation, PPT. Precipitation is formed in some chemical reactions. Okay, before going to the chemical reaction complete explanation, we have to know about chemical equations. Before the chemical reaction, we have to know about equations. So equations means it's very simple. These chemical equations, they are symbolic representation of chemical reactions. So symbolic representation of chemical equations, chemical reactions. In this chemical equations, we know about reactants, product. So reactants and product. So we can observe the reactants and product. Reactants, they are present in LHS. Products, we can get it in RHS. So here representation of chemical reaction. Chemical equations means a simply representation of chemical reaction. We can write the chemical reactions in three types, that is word equation, skeleton equation, and balanced equation. And we have the plus arrow mark, and we can also mention the solid, liquid, and gaseous state, and also we can mention the aqueous solutions. So these are all the symbols, they contain the chemical equation. So best example we have that is the activity, that is burning of magnesium. First of all, you have to know about elements. Magnesium is one of the metal, but it is one of the soft metal. Not completely soft like gold, but it is a little bit soft because it is easily catch the combustion, because it is easily catch the fire. So magnesium, when we burn the magnesium, this magnesium, it is react with the oxygen present in the air. So magnesium react with oxygen and it will produce the magnesium oxide. This is the word equation. So below that I written that magnesium means symbol is Mg, oxygen means O2. I written that MgO. This is the skeletal equation. It means unbalanced equation. So next one we have the balanced equation. Balanced equation means that is 2Mg plus O2 and it will gives 2MgO. It is balanced equation. Okay, how can we balance the equation? So how can we balance the equation? This is an important one because we can get easily at least 2 marks for balancing of chemical equation. In your 9th standard, you have the chapter name called structure of atom and molecules. Those two chapters, they are the basics for the 10th standard chemistry chapters, because in 10th standard chemistry we have the 5 chapters. In that 5 chapter, the 4 chapters, they have lot of chemical reactions, except that one periodic table. So except that we have the 4 chapters, those are having the lot of chemical reactions. We have to understand the chemical reactions means we have to know about structure of atom and atoms and molecules. That is the backup for these chapters. So Here we have the one of the chemical reaction, that is Fe react with H2O and it will produce Fe3O4 and the gas is evolved, that is H2. So we have to balance this. So I written in the black ink, that is the chemical reaction. After that I wrote that in blue ink, that is the balanced chemical equation. I will write that, I will wrote that after the balancing of chemical equation. So how can we balance it? Means it's very simple. In the LHS, in the reactants, we have Fe, hydrogen and oxygen. So Fe, hydrogen and oxygen. In the reactants, we have the one Fe. In the product, we have the 3 Fe, 3 ion. In the reactant, we have the 2 hydrogens. In the product, we have the 2 hydrogens. They are equal. In the reactants, we have oxygen 1, but product, we have the oxygen 4. So we have to balance it. Initially, I will balance the iron. I have the iron only 1 in reactant, but product it has a 3. So I will multiply by 3 in 3 to 1. So 1 into 3, it will be 3. I will write the 3 before the Fe. So it will become Fe is equal. Fe is equal, nothing to worry. Hydrogen is already equal, nothing to worry. Here also H2O, so H2, and here we have the H2. But oxygen is unbalanced. So in the product we have the O4. See that Fe3O4. So in the reactant it has a only 1. So I will multiply by 4. It will become 1. So I have to put the 4 in. I have to put the 4 before the H2O. So it will become 4H2O. When I put the 4, so hydrogen become 8 and oxygen become 4. So what will I do? I have to increase the hydrogen in the product. So that's why I have to put 4. I have to multiply the product to hydrogen into 4 times. It will become 8. So like this chemical reaction is balanced. First of all, you have to understand the chemical reactions means we have to solve the unbalanced equations. You have to practice it, otherwise you cannot get very easily this one. So this is not a direct question, this is analyzing question. You have to learn little bit mathematics here. So you have to practice this, otherwise you cannot get easily 2 marks. So you have to concentrate here more. So after that the chemical reaction, they need some external phenomena. Some chemical reactions, they need temperature, pressure, catalyst. So in these conditions only the chemical reaction happens. I will give some examples here. The best example is here. Carbon monoxide is react with hydrogen. The carbon monoxide, it is easily not react with hydrogen. It needs some external temperature. If you add some external temperature only, the carbon monoxide is react with hydrogen and it will produce CH3OH. CH3OH means it's a methanol. So another one best example is, that is photosynthesis. So photosynthesis means for the photosynthesis, the plant, it need carbon dioxide and water. Those are present in the chlorophyll. Of course, the plant can get the carbon dioxide anytime, also in night time, also it can get the water every time, anytime it can get the water. So but it is not happen. But in the night time photosynthesis is not happen. So it happens only in morning, because it needs sunlight. So photosynthesis is happened only in the presence of sun. So sun is, it will plays the major role. So next one we have the types of chemical reactions. So types of chemical reaction, first reaction is combination reaction. So word itself tell that combination or combining. So here we have A plus B, it will gives AB. It means A and B, they are combining each other. We can call it as combination reaction. So the best example is hydrogen is reacting with oxygen, it will produce water. So this is the best reaction. You can directly give example as formation of water. So in the textbook we have some activities. So we have the best example, that is calcium oxide react with water. So calcium oxide uh, calcium oxide react with water, it will produce calcium hydroxide and water. Calcium hydroxide and water, it means it's a lime. We are putting the lime in water, lime, it will produce a lot of heat. It will produce lot of heat, and that water, that liquid is, it start boiling, it will produce a milky liquid, that is calcium hydroxide, and also it will produce some amount of water. So for this calcium hydroxide, we are using the coloring to the walls. If we color the walls, if we coat the walls by the calcium hydroxide, they will react with carbon dioxide. If we paint the uh, carbon hydroxide on the wall, it will react with the carbon dioxide present in the air, it will produce calcium carbonate. It is a best, it will be shine more, calcium carbonate, and also it will produce some amount of water. So this is the combination reaction. Of course, we have many examples like burning of coal. Burning of coal, anything you will burn, it will produce some amount of carbon dioxide. Anything, it will produce some amount of oxides. So if you burn the carbon, it will produce carbon dioxide. We have another one, that is exothermic reaction. If you burn the natural gas, that is CH4. If you burn the CH4, that is react with oxygen, it will produce carbon dioxide, and it will produce some amount of water. CH4, it's a carbon compound. We will study this concept in the carbon and its compounds chapter. And another one is the respiration. Respiration is the very best example, because respiration, it will produce some heat. It's also one of the exothermic reaction. In the reaction, the heat is evolved, means that is exothermic reaction. So we are respiration is always, always active, it is always happening in our cell. So we can call it a cellular respiration though. So that's why the human body is, it has some amount, it has some that much of heat. Otherwise it is very cool. If if the dead body is completely cooled, because there is no respiration. So next concept is decomposition reaction. Decomposition reaction, it means decomposing means dividing. We are composed material is here, we are decomposing that material. It means we are dividing the compound. So we are dividing the compound, we can call it as decomposition reaction. Here we have the best example, that is we are decomposing the components, we are decomposing the compounds by electric current. We are decomposing the water by electricity, we can call it as electrolysis. So here we have the water, and we are put some two electrodes, it has positive and negative charge, we are passed some amount of electricity. So there is water means H2O, they are liberated, they are divided. So hydrogen and oxygen, they are separated. Hydrogen is collected in cathode, and and oxygen is collected in anode. So this is called as decomposition reaction by the help of electricity. Next one, we have the we can decompose by the help of sunlight. We have the best example, that is um, silver chloride. Silver chloride means AgCl. So we have the silver chloride here. If you open the silver chloride, if we kept the silver chloride to the sunlight, the silver chloride is divided, it is decomposed. Into silver and chloride, it is separated. And next one, best example, that is silver bromide. If you keep the silver bromide on the open sunlight, they will divide it into silver and bromide. And also we have another example, that is burning. By the help of burning or heating, if you have the ferrous sulfate, FeSO4, if we take it in the test tube and you will start heating, so it is divided by the help of heat into Fe2O3, and it will produce sulfur dioxide and sulfur trioxide. So FeSO4 ferric oxide is dividing. And next one, calcium carbonate. Calcium carbonate, we are studied that is calcium carbonate in the combination reaction. So same thing, we are getting the calcium carbonate and we are heating that. So by the help of heat, it is divided, it will produce calcium oxide and carbon dioxide. So chemistry, it is very beautiful concept. So we know how to combine the elements, and we know how to divide the compounds into elements. So this is the uh, decomposition reaction. And another one of the example, that is lead. We can also lead nitrate, we can also divide by the help of heat, it will produce lead oxide and nitrogen oxide, and oxygen is produced. And third one chemical reaction is displacement reaction. Wow, the name itself explain that displacement, place is changing here. This is the best one. If we have the copper sulfate solution, we have the copper sulfate powder, we are we are poured in the liquid, it will become copper sulfate solution. We will put iron piece in the copper sulfate solution. After some amount, after some time, the copper, it will place down the iron, and also some amount of iron, it is react with copper sulfate solution, it will both are changes their color. So we can write it as Fe plus CuSO4. Fe means iron, CuSO4 means copper sulfate solution. Both are reacting each other, and iron is more reactive than copper. Iron is more reactive than copper. Iron, it will occupy the place of copper, so copper is separated, displaced of copper. Copper is displaced by iron. So same experiment will continue by zinc. So zinc is more reactive than copper. Zinc will occupy the copper place as it is. And lead with copper chloride. So in the lead, it is a more reactive than copper. It will occupy the place of copper. It will become lead chloride. Lead chloride. So lead chloride and copper is separated, but I written wrong there. That last one Pb is, it's not a Pb, it's a Cu. So next one, we have the chemical reaction, that is double displacement. We are studied the displacement, that is the third one. So we have the double displacement. It means two elements are displacing. The best example is sodium sulfate and beryllium chloride. Sodium sulfate and beryllium chloride, we are combining each other. So here the sodium is react with chlorine, it will become sodium chloride, NaCl. And beryllium it is react with sulfate, so SO4, it will become BaSO4, beryllium sulfate. So it is called double displacement. Best one this is. And next one, we have the oxidation reduction. Oxidation reduction means it's a very simple one, so we can explain it by the example. Okay, here you have to come here. So there is copper oxide is there. So copper oxide, we are heating the copper oxide with hydrogen. So we are heating the copper oxide with hydrogen. So what happens here? Copper oxide, it has the oxygen. That oxygen, it is react with hydrogen and it will produce the H2O, and it will separate the copper. Observe that product, that is Cu plus H2O. What happens here means copper, it loses the oxygen. We can call it as reduction. So loss of oxygen, we can call it as reduction, and gain of oxygen, we can call it as oxidation. So hydrogen, it gain the oxygen, copper, it loses the oxygen. Copper loses the oxygen, it means reduction. So hydrogen to gain the oxygen, we can call it as oxidation. So we have many more examples. Zinc oxide plus carbon, it will become zinc plus carbon monoxide. So zinc loses the oxygen, we can call it as zinc, it will become zinc. And carbon, it absorb, it will react with oxygen, it gain the oxygen, we can call it as oxidized. So it is very well. And next, we have the effect of oxidation reaction in everyday life. Best example is oxidation means addition of oxygen. So here what happens means the oxidation, it will cause some effects, that is corrosion of iron. so iron will corrode, rusting of iron. Of course, corrosion is also happens on copper. If you have carbon vessels in your home, you have to wash the carbon vessels every 2 to 3 days. Otherwise, they will look very brown because they will oxidize it. They will react with oxygen and they will produce some amount of like they are corrosing. And we have the rancidity. Rancidity means when fats and oils stay open for a long time, they get oxidized and become rancid. Means their taste is changed, their smell is changed. It is not good for edible. Their taste is completely changed. We cannot smell those things. So, by the oxidizations, food, that is fats, oils, they are what we can call, they are losses their taste and smell. So that's why we cannot use them. You use them further. So this is the one of the effect that is called rancidity. And we have to keep the, so that's why we have to keep the food in airtight containers, so it will avoid the supply of air to the product means food. And nitrogen prevent the chips to get oxidized. Of course, in this time we can get the packed chips. Those in that packed chips we have very less amount of chips and more amount of hair. But that is not a simple hair, that is nitrogen gas, because those nitrogen gases, they are preventing the chips, from the oxidization. Okay, so this is the chemical reactions and equations. It's a very simple chapter. This is just I explained the points. You have to practice very well. Other than the practice, you cannot achieve the good goal, because we are just facilitator. You have to work more. This is the 10% of my, this is the 10% you achieved here only. So you have to work it more. That is the 90% you